Alright, welcome to another math video. Today we're going to be talking about multiplying polynomials. We talked about adding them yesterday, or adding them last time. And so today we are talking about multiplying them. Another way we can talk about multiplying polynomials is just called distributing for days. Okay? Okay. So, there's a few ways we can multiply polynomials together. Essentially, what we can, for our first sort of application that we're going to talk about is just normal distribution. If you have, say you have like 3x squared times x squared plus 4. Okay. Here we have a monomial times a binomial. And both of these are polynomials. So what we're going to do with them is we're just going to distribute. We're going to multiply 3x squared by our first term, 3x squared times our second term. So it's 3x squared times x squared gives us 3 times x squared times x squared is x to the fourth, plus 3 times 4 is 12, and then the x squared comes along for the ride. So 3x to the fourth plus 12x squared. We're just going to take whatever is outside the parentheses and distribute it to everything inside the parentheses. So then, what we can talk about is if we have a more than one thing times more than one thing. All right. Apparently, I had things paused for a while I was talking through a bunch of things and recording. So we'll just talk through what's going on. So, this guy right here is our original problem. We're given a binomial times a trinomial, and we just distribute a bunch of stuff. Distribute the x to everything in the second parentheses, distribute the negative 2 to everything in the second parentheses. So x times 1 gives us x times 1 gives us x squared, x times 3x gives us 3x squared, x times x squared gives us x cubed, negative 2 times 1 gives us negative 2, negative 2 times 3x gives us negative 6x, negative 2 times negative x squared gives us positive 2x squared. And then from here, we're going to collect all of our terms and write them in a standard form. So we're going to find the biggest exponent first. Any other x cubes would get added to this. Since this is our only one, we just write this down. Then we take our x squared terms, 3x squared and 2x squareds, adds up to 5x squareds. Negative 6x's and positive 1x's gives us negative 5x's. And then we have negative 2 and no other constant terms, so that gets written down. We also have another more visual way we can write this, where we would put these in like the box sort of form. So we would put each of our terms separate across the top for one of our two polynomials, and then the other polynomial gets written along the side. And then each cell, so to get the answer for this cell, we would take this term times this term. The answer for this cell, we'd take this term times this term, and we would get the answer for this one. And we would do that for all the cells, and then we would add up anything that has a common exponent. So x cubes, x squared, x's, and constants, they would all get added up together. All right. The more terms you have in any of your parentheses, the more terms you have in your parentheses means you have to do more multiplication problems to start off. So if you have like 3 terms times 4 terms, you're going to have 12 total multiplication problems you need to do before you can actually write them down together. Okay? So, last is going to be sort of a shortcut, which might feel like a long cut, but it's really just a process that you can sort of turn the crank to and get to an answer. But first, in order to look at that, in order to sort of identify and use that, we need to talk about Pascal's triangle. So something that looks like this: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is going to keep going. All right. So to get any row, we're always going to start with the number 1. Always going to start with the number 1, and then it's going to The second row is going to have 2 ones. Then we're going to take a third one. Then we're going to take this one and add them together to get 2 and end up with a 1. The next row, we're going to add a 1 on both sides. And then for every term in the middle, we're going to add the 2 numbers above it. All right, same thing here. Start with a 1, add these 2, add these 2, add these 2, and then you get your next term. So what I want you to do is I want you to come up with the next row, the next 2 rows for this Pascal's triangle. All right, take a second, pause the video, and do that. So hopefully you found these next few rows of Pascal's triangle. You can keep going with this thing forever, with this Pascal's triangle forever. So a couple things. This row right up here, we're going to call this row 0. Row 0 is right here, this first row. And then if you take a look down this column here, this will tell you the number of the row. The second number, the first number that's not that first one, will tell you the number of the row of that column. So like this guy right here, this would be row 7. Okay? So how is this useful? Well, I'm going to just sort of zoom out, and we're going to keep this on our paper so that we can see it. But if we have a problem, if we have a question, something like, let's say we have x plus y to the third power. Now, we could expand this and multiply it all out. So let's do that. So this is going to be x plus y times x plus y times x plus y, right? X plus y to the third power means we're multiplying x plus y times itself 3 times. So then we're just going to take a pair of these and multiply these out. So I'm going to take these second 2 and I'm going to multiply these out. X times x gives us x squared. X times y gives us xy. Y times x gives us xy. Oops. And then y times y gives us y squared. And we can condense this a little bit. We can simplify this. We can get x squared plus 2x plus 2xy plus y squared. So we have that times x plus y. So if we take x times x squared, that gives us x cubed. X times 2xy gives us plus 2x squared y. Y times 2xy gives us plus 2xy squared. And then y times y squared gives us y cubed. And my apologies. Let's see. I'm making a mistake. Let me back up a little bit. All right. I don't think I multiplied everything by what it was supposed to be multiplied by. There we go. All right. Let's try again. X times x squared gives us x cubed. X times 2xy, 2x squared y. X times y squared, there we go, that's where I messed up, plus xy squared. And then y times x squared gives us plus x squared y. Y times 2xy gives us 2xy squared. And then y times y squared gives us plus y cubed. Okay, and then if we collect like terms, we combine like terms here, we have x cubed plus, if we find, so we have, that's all of our x cubed terms. And then now let's find all of our x squared y terms. So here we have an x squared y as well. So that's 3x squared y's plus, let's see, let's find our xy squared terms. Xy squared. So then we have, let's see, we have 3 xy squared terms plus, and then this is our only y cubed term, plus y cubed. Okay? Now if we take a look at this, and let's say I just put 1s in front of these. We raise this to the third power. Well, look at the third row of our Pascal's triangle, 1, 3, 3, 1. If we take a look at the coefficients of our multiplication problem, we get 1, 3, 3, 1, and that's not a mistake. Any of these rows that, or any of these things that you use this for, you're going to have this sort of pattern. So a way that we could have done this a little bit more easily, a little bit more quickly, and a little bit more just sort of turn the crank like, would have been if we take and say, okay, I identify 3 as being my row of Pascal's triangle that I'm looking at. So I'm going to take Pascal's triangle's third row, and I'm just going to write it down. 1, 3, 3, 1. Then I take my first term and any signs along with it, and I write those down. X, 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 X. And then I take my second term and any signs along with that, and I write that down. So then that'd be Y, 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 Y. With my first term, then once I have all my terms written down, I'm going to add exponents to each of these. So the first one, I'm going to start with the number that we raised our exponent to. So 3, 2, 1, 0. And I'm going to count down. For the second term, we're going to count up. 0, 1, 2, 3. So now, we're just going to do these multiplication problems across each row. So 1 times x cubed times y to the 0. Any number to the 0th power is always going to be 1. So 1 times x cubed times 1 is going to be x cubed. And then 3 times x squared times y to the first is going to be 3x squared y. 3 times x to the first times y squared is going to be 3xy squared. And then this last row is going to be 1 times y cubed, which is going to just be y cubed. And then we can write these down in order. So x cubed, and along with any signs. So x cubed plus 3x squared y plus 3xy squared plus y cubed. And if we look here, both of these are the same numbers, which in the grand scheme of things, is it that much longer to just multiply out the 3 terms together? Not really. There's not much complicated going on, but when these things start to get more and more complicated, this can break it down into very straightforward, very basic math multiplication problems that you've been very used to. So with that, I'm going to do one more example, but you're good to go ahead and get started on your homework now. If you want to stop the video and then maybe come back if you have a question on one of the problems or a couple of the problems for your homework, but you're good to go ahead and get started on your homework now. So I'm going to go ahead and just pause for a brief second. So if you want to stop the video here and go, you're welcome to do so. Alright, so let's say we are looking at a slightly more complicated version of this. So let's say we had something like, 2x minus 3y. That's our term, and then we're going to raise that to the 4th power. Okay? So, using the example, using the Pascal's triangle thing, we're going to look at the 4th row of Pascal's triangle. Okay, the 4th row. So again, we're just going to, our first step is going to be just to write down that row. So 1, 4, 6, 4, 1. Okay, then we're going to take our first term and write that down. So we have 2x, 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 2x. Then we're going to take our second term, negative 3y, negative 3y, negative 3y, negative 3y, and negative 3y. Okay? Then we're going to, I'm just going to go ahead and throw these in parentheses because we want to make sure to hit everything with our exponent. So then we're going to start with the 4, 3, 2, 1, 0, 0, 1, 2, 3, and 4. Okay? So now, we want to expand these and then multiply them together to get our individual terms. Okay, so this one is going to be 1 times 2 to the 4th power is, let's see, 2, 4, 6, 8. So 2 times, no, first 2, 4, 8, 16. Sorry. 2 to the 4th power is going to be 16 times x to the 4th. And then anything to the 0th power is going to be 1. So 1 times 16 16x to the 4th times 1. And then we're going to keep going with this. 4 times 2 to the 3rd power is 8 x cubed. And then negative 3y to the 1st power, a negative times nothing else is going to stay negative. So we're going to still be multiplying by negative 3y. So then 6 times 2 squared, so 2 squared is 4, x squared. Now, if we take negative 3 times negative 3, that's going to be positive 9y squared. And then we're going to have 4 times 2 to the 1st is 2x. Negative 3 times negative 3 is positive 9, times another negative 3 is going to be times negative 27y cubes. And then we're going to have 1 times, let's see, 2x to the 0th power. Anything to the 0th power is going to be 1 times negative 3 to the 4th power is going to be the same thing as 9 times 9, which is 81 times 81y to the 4th. Now, if we just multiply each of these across, we'll get each of our individual terms. So 1 times 16x to the 4th times 1 is going to be 16x to the 4th. 4 times 8 is 32 times negative 3 is negative 96 x cubed y to the 4th. Whoops. X cubed, just y. X cubed y to the 1st. So now we're going to have 6 times 4 times 9. So 6 times 4 is 24 times 9 is a number that I can't think of off the top of my head. So I'm going to run a Desmos real quick. All right. 6 times 4 times 9. 216. All right, 216 is our number. 216 x squared y squared. 216 x squared y squared. Let's see, 4 times 2 is 8 times negative 27. Again, conserve the brain power. 4 times 2 times negative, times negative 27 equals, really? Well, that's fun. 4 times 2 times negative 27 is going to be negative 216. Negative 216 xy cubed. And then 1 times 1 times 81 is going to be 81 again, 81y to the 4th. So our final answer, we would just rewrite these in that addition problem form. So 16, or that polynomial form, x squared minus 96 x cubed y plus 216 x squared y squared minus 216 xy cubed plus 81y to the 4th powers. This would be our expansion of this guy, which again, you can do if you just 2x minus 3y times 2x minus 3y times 2x minus 3y times 2x minus 3y. You can do this. You can get to this by doing this stuff. But in my opinion, this gets to be a little bit easier once you have the sort of the format and everything sort of worked out. This gets to be just sort of regular small number arithmetic that you just have to keep track of. All right. So with that, I will have an assignment for you on Classroom. If you have any questions, let me know. I'll be live at 1 every single weekday, and so with that, have a wonderful day, a wonderful time, a wonderful weekend, and I will see you guys next time. Bye bye.